Hello dear students, good day to each of you, and I would like to welcome all of you to our fifth session of our science class. First of all, I would like to congratulate to those who were able to receive an excellence award. Congratulations to all of you for doing a great job that you were able to receive the principal's list. Some of you have received the with honors award, and some have received the with high honor excellence award, and some also receive. I'm not sure if there's some who have received the with highest honors award, but probably there are some of you who have received the with the highest honor academic excellence award. Congratulations, and also to those who will receive probably in the second quarter. Okay, that was only in the first quarter. You can still do better. To those who were not able to receive, then you can do your you can do better for the second quarter. Okay, so hoping that you can also receive that one. Okay, if not, then just do your part. Okay, so this today we will be learning in other topics. This could be as complex, probably a complex topic, but if you just put a focus on this, then you will make this will be an easy topic. So please be reminded also to please secure your own periodic table of elements, because probably we will be using that starting this second quarter. You can use that also in the next grade level. Okay, so before we will continue, shall we have a prayer, and we'll ask guidance from the Lord to help us understand our discussion today. Okay, shall we pray? Gracious Father in heaven, thank you so much for today, and thank you for this privilege to learn, dear Lord. And as we have our discussion, may you help us, dear Lord, that the students will be able to understand the things written here in the modules, and help us, dear Lord, that we can glorify you as we learn from our topic this day. Thank you for guiding us always, dear Father. Thank you for protecting us and providing us all our needs. We entrust everything to you. In Christ's mighty name we pray. Amen. Okay, so once again, good day. And I'm not sure if when you are going to see this recorded video. And I made this for you to be guided in as you answered your modules. Okay, so you can see here in the screen is our module. So please get your modules also, because some of the answers will be provided, so you can take down notes of the important things that we are going to discuss, because probably I will add some illustrations or some discussions in our module. So our topic for this module is about electronic structure of matter. Okay, so because we'll be focusing on the chemistry. So before, in my time before, it was when the curriculum is not yet a spiral curriculum, then for the first year or for the grade 7, we focus on science and health. For the second year or grade 8, we focus on biology. And for the third year or the grade 9, we focus on chemistry. And for the fourth year or the grade 10, we focus on physics. But today we are in the spiral curriculum. That's the reason why you will undergo all the different in your level. You will learn the science and health, the biology, you have the chemistry, and also the physics. And now we will be focusing on physics. So we will be tackling about matters, the electronic structure of matter. But before that, we will have our first activity. So we have here, as you can see, these are the books of the Bible, and this is the periodic table of the Bible. So the books of the Bible was written like or arranged like a periodic table. Okay, you can see there the Genesis, Exodus, the Numbers 1, that was the book number above, and below is the number of chapters. Okay, you can see there Genesis is 50, Exodus is 40, so Leviticus is 27. So those are the number of chapters each book of the Bible have. Okay, so below there is number 1. What you are going to do is you are going to write the full name. Okay, you are going to write the full name of the book of the Bible. For example, the Bible with symbol EX. So what book of the Bible that has a symbol EX? So you have here the Exodus. What you're going to do is to write the Exodus here. For the number 2, Cl. So this is not a chlorine. So in the real periodic table, we have here the chlorine, but here in the Bible periodic table, then you are going to write the name of this book. Okay, so that will be in number 1, number 2, number 3, and number 4. Number 5 to 8 is we are going to write the major prophets. So what are the major prophets in the Bible? You can see there below the legend or the symbols. There is a major prophet with this color. So you are going to locate which color of the Bible is the same with this below. So you are going to write those books of the Bible from number 5 to number 8. Okay, so this module will discuss the historical development of the atomic model as well as the position of electron in each shell of an atom. Okay, by the end of this module, after we are done with this module, I hope that you will not forget right away. You are going to describe the development of atomic model, because the atomic model has a development from this simple one into a complex one which is being used today. So what are those? We will know them later. Okay, so the second one is you can identify the position of the electron in an atom, because we know that the electron is the negative charge of an atom, but that is an active charge of the atom. So inside an atom we have the proton, the neutron, and the electron, and this electron is the active charge of an atom. Okay, so you can identify that one. So I put a note here below to please secure your own periodic table of elements so that you can have or you can use your own periodic table of elements. Okay, so now let's proceed to our discussion. We have only 30 minutes because I am going to cut this 30 minutes so that masulod ra siya, dali ra siya ma-upload sa YouTube. Okay, so I will be uploading this to YouTube. Don't forget to subscribe, joke lang. Okay? So let's proceed to the historical development of the atomic model. In the second page of your module, you can see this one. So I will be changing my screen now. Okay, so you can see this one in the second page of your module. Okay, so a history of the atom theories and model. As you can see here, John Dalton, the first one who wrote, who proposed that an atom is like a solid sphere. Okay, it's like a circle or a bowl, which like this one, and he believed that this is a solid sphere. So he proposed that one, and that was in 1803. Okay, Dalton drew up the ancient Greek idea of atom. The word atoms come from the Greek word atomos, meaning indivisible. Okay, this theory stated that atoms are indivisible. Those are a given elements are identical, and compounds are combination of different types of atoms. So that was John Dalton who proposed this idea that an atom is a solid sphere. That was in 1803. So after that, after Dalton, 101 year after, okay, it was a century and one. That was in 1904. G.G. Thomson realized that an atom is not just a solid sphere, but still he believed that an atom is a solid sphere, but there is an inside element. Okay, there is an inside element or inside component of that atom. Okay, so he believed that an atom, a solid sphere, has a component of a positive and a negative charge. That's the reason why in the plum pudding model you can see there a positive and a negative charge. So they do not know what they call that one. So if it's real, but he believed that an atom has a positive and a negative charge. So that's the reason why that Thomson discovered electrons, okay, or which he called corpuscles. So it's not yet an electron before. That was a century and 1 year after John Dalton have discovered that an atom is like a solid sphere. So after that, a few years, so how many years? 7 years after, Ernest Rutherford believed, okay, they did not argue, okay, so they did not argue with each other, but the next scientist who discovered the atomic model is or carry the idea of the one who discovered it first. So Ernest Rutherford in 1911, he realized that G.G. Thomson is right, or he's correct, that an atom has a positive and a negative charge, but Ernest Rutherford believed that and the electron or the negative charge has a certain orbit. Okay, that was Ernest Rutherford in the 1911, and he proposed that the electron or the negative charge of an atom has a certain orbit. That's the reason why you can see this one. Okay, this is the orbit of the electron. So the positive charge is just at the center, and the negative charge is the one who is rotating or revolving around the positive charge. Okay, that was in 1911. 2 years later, 2 years later, so again Niels Bohr. Okay, this one is the nuclear model which Rutherford proposed, which is being used also. Okay, so in many books, this nuclear model is being used. After that, 2 years later, so Niels Bohr also proposed another design, because he believed, like Ernest Rutherford, he believed that the electron or the negative charge travel in an orbit, but he believed that its orbit has a certain level of electron, okay, or has a certain level of charge. It's not the same with all the levels in each shell. That's the reason why he put a shell in its orbit. So the first one here is the first cell. This one, I hope you can see my cursor. This is the first level, the second level, the second shell or the second orbit here, and the third level, the third orbit here. There will be the fourth, the fifth, depending on the number of electrons. Okay, so that was the planetary model that was being proposed by Niels Bohr in 1913. Next one, 13 years later, another scientist or another chemist also state or propose another model, which is a quantum model. Okay, a quantum model, probably you are not really familiar with this quantum model, but this is being used in our chemistry books, especially in college. But most of the books in high school and the elementary, or in high school especially, they are using the planetary and nuclear model, because quantum model is a bit complex. Okay, this is a bit complex because a quantum model has a specific field here. Okay, around this charge is the electron, still the electron here, but it has a lot number of electrons depending on an angle. This is a 3D model. Okay, depending on its angle. That's the reason why quantum model is not really used in books in high school. Only the nuclear and planetary model. So these five are the development or the historical development of an atom, that started by John Dalton in 1803, G.G. Thomson in the 1904, Ernest Rutherford in 1911, Niels Bohr in 1913, and Erwin Schrödinger in the 1926. Probably there will be a student from WMA Academy who will be the one to next to develop another design of the atomic model. Okay, we are not probably we cannot judge the time or the individual. Basin di ay nga there will be one from the WMA Academy students who will be the next, okay, nga mo design na pod sa model, because you can discover another thing. Okay, so that was the development of our atomic model. Okay, you can see that in your module, in the page 2 of your module. Okay, so let's switch back to our module. So here, let's proceed to the next discussion that we have, which is the position of electron in an atom. So you have to study this one, because this will come out in the activity in the next page. Okay, so here in the second one, this may be complex if you face this just right now. Kung karon pa mo nakakita ni, this will be a bit complex to you, but if you just focus on learning this one, then this can be simple. Okay, we are going to tackle about the position of electron in an atoms. Okay, so here you are already know that in the nucleus of an atom is the neutron and the proton, and around it, or the active charge is the negative charge. Here, this is the planetary model, and you can see here that this one in each shell, so we have here the blue one, the negative charge is the electron, the positive is the proton, and the green one or the blue one, so color ani, is the neutron. Okay, how to determine the number of electron in an atom? Okay, so this is a structure of your periodic table of elements. Some of your periodic table is not really the same with this one, but most of the time the big number is the atomic number. That was the atomic number. And remember class that the atomic number is equal to the number of proton. Okay, hinumdumin na ninyo ha, nga ang atomic number that is equal to the number of proton. Okay, so this one in the this one here, this is the total of the number of proton and the number of neutron. Okay, the atomic weight. That was the atomic weight here. The atomic weight is the total of the number of proton, which is the atomic number, and the number of neutron. Now, how to determine the number of electrons? The number of electron in a neutral atom, meaning to say there is no charge, it's not a charged atom, is equal to the number of proton. Okay, remember that in a neutral atom, the number of electrons is equal to the number of protons. So, in short, the number of electron is also the same with the atomic number. For this one, this is a element sodium, and the atomic number of sodium is 11, and this is a neutral. If sodium is a neutral atom, then the number of proton is also 11. Okay, so please remember that one. Again ha, the number of electron in a neutral atom, the number of electron is equal to the number of proton. And the number of proton is the same with the atomic number of an element in the periodic table. Okay, inyo nang timanan. Now, the mass number of an atom, as I've told you a while ago, this one, the atomic weight is the total of the number of proton and the number of electrons. So here, in the element sodium, a non-charged element, since the number of proton and the number of electron is the same, so total anak niya is 22. Okay, 22. Siya. Probably you can see that there is a decimal point. So this is not the same with the mathematics. So in chemistry, so you cannot make this to round up, since so we know nga after a decimal, when there is a decimal point after 5.5, it will be round up, so this will become 23. But in chemistry, dili na siya pwede. Okay, so it will stay at is as 22. So here the atomic number is equal the electron, or the number of electron is equal to the number of proton here. Okay, let's proceed. Energy level in an atom. So as I've told you a while ago, in the planetary model that was proposed by Niels Bohr in 1913, this one, okay, so he said that each level or each shell has a specific number of electron. Okay, this one, this K here is the first energy level, the second the L. So he put a letter, shell letter, so that they can easily identify that one. Okay, here as you can see in the figure in the left, this one, this figure, okay, this figure, I hope that it's clear to you. So just see, watch or just open your module so that you can see it clearly. The first one here, this is the nucleus of an atom, which contains the proton and the neutron. So the first level here is contains a number of electron, the second contains another number of electron, and the third one still contains the number of electron with a specific number, a specific charge. How many? Okay, how many electron that does each shell can hold? We have here. So in this example, 1, 2, 3, 4, only 4. But according here in our illustration, this one in this table, there are 6. Okay, so here in this illustration, there are only until the N, which is the fourth energy level. This one, but in this table is until P, or the 6th energy level. Okay, how many electrons in each shell? Okay, in the first level, or in the first shell, it contains its capacity is only 2 electrons. Okay, only 2. Just remember that. in the second level, its capacity is only maximum of 8 electron. Okay? So, understood? 8 electrons only. At the third level, this one, 1, 2, 3. So, here, in the third level, the electron capacity of this one, na may mag-atang-atang. In the third level is 18. Maximum of 18. It cannot hold 19 electrons. Only 18. It can hold below 18, but it cannot hold more than 18. So maximum. At the fourth one here, the fourth level, it can hold up to 32. So as you can see, the first one can only hold 2, the second is 8, the next is 18, the fourth one is 32. The next shell, it can hold more number of electrons. Okay, the electrons can be, or the number of electrons that it can hold will become larger and larger. So 2, 8, 18, 32. The fifth one, if there's still another shell here, it can hold 50 electrons, and the next one, the sixth one, it can hold 72 electrons. Okay, so that will be the number of electrons it can hold. So you have to use this one in your activity. You have to refer from this table in your activity below, because you have to remember that each shell has a specific number of electrons that it can hold. Okay, so like for example, in the sodium, element sodium here, as we know above here, as we know above, that the element sodium has an atomic number of electrons. So considering that this atom is a neutral atom, so we know that the number of electron here is also 11. Okay, considering that is a neutral. So let's put it here. So remember from this table, that in the first shell here, this is sodium, Na stands for sodium. So in the first shell, you can see there that it can only hold up to 2 electrons. The X, kanang nakabutang nga X din ha, that means the electron. So in the first shell, it can hold only 2. So it cannot hold up to 3. Try to remember that ha. Okay, you are going to put 2. Okay, next one, since there are still more electrons to put, then you are going to add another shell. In the next shell, you can put, or it can hold up to 8 electrons. So let's count in the second shell. 1, 2. I hope that you can see my cursor. The X1 there is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that will be it already has the maximum number 8. So how many? From the first shell to the second shell, we have already 10 electrons. Why? Because 2 from the first shell, 8 from the second shell, a total of 8 electrons. Now, sodium has 11. So nasa sobra isa. Okay, what we are going to do is to add another shell. So we put the third shell. This third shell can hold 18. Okay, this shell can hold 18. So since na may sobra isa, because the electron in the sodium, considering it's a neutral, it's 11, then you are going to put 1 here. So how many? The total number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, probably you might ask, Sir, why we are not going to write here the 11 in the third? Okay, why we need to write? Why we need to put the first shell, the second shell, the third shell, which we can. In the third shell, it can accommodate 18 electrons. So we have to remember that the shell has a specific level. That's the reason why, and its level has a specific electrons that work in it, or that moves in it. That's the reason why we need to put electrons starting at the first level. Okay, we should not put in all the electrons in the last level. We need to fill in first the first level. Then when the first level is full, then we need to move to the second level, to the third, to the last. So this is not just the same when we go to church. When we go to church, as you can see in the church, kung himantayon mo, makabantay gid mo sa church nga the first nga mapuno in the benches sa church are the one that is in the back. Okay? Di ba tinuod, no? But when you go to the concert, when there is a concert, then the first or watch baka mo mga pageant or mga kanang boxing, so the first chair or benches nga ma-fill in is the front. But when you go to church, the benches to be first nga ma-fill in are the benches at the back. I'm not sure. I don't know unsay reason ana, but people kanang gusto sila nga magpalikod ra. Even in the classroom, okay? It's the same. So I hope that you understand that, that in the first level you have only 2, the second is 8. So considering that that sodium has 11 electrons, then you are going to count how many here is 11. Okay, so understand this one because this will be our activity in the next page. Okay, so you have to remember, we have 5 minutes more. Okay, so let's proceed. How to find the number of electron if the atom is a charged atom? Okay, if a charged atom, it's sorry. If the atom is charged, the number of electron is no longer the same with the number, or it's no longer the same with the atomic number, because the atomic number is the number of proton. So what you're going to do, there is an equation here, which is neutron, the number of, this is not neutron, the number of electron or the negative charge here is equals to the number of proton plus or minus atomic charge. Okay, plus or minus. When are you going to add or subtract? Okay, there is a description here, but to make it a simpler, so I put example here. Let's proceed to the example. So remember this equation, the number of electron is equals to the number of proton plus or minus, okay, plus or minus the atomic charge. Okay, what is the charge? If the charge is positive, what you are going to do? If the charge is positive, mabali na siya. Okay, it will break the law of mathematics. Because here, if the charge is positive, you are going to subtract. Okay? You are going to subtract, imong minusa na siya, imong tanggalan og isa. If the charge is positive. But if the charge is negative, you are going to add. Okay, inyo nang timanahan, please remember that one, that if the charge is positive, you are going to subtract, and if the charge is negative, you are going to add. Why? Because we focus on the electron. Okay, we focus on our artist here, or the main focus, the proponent of this one, the main actor of this activity is the electron, and the electron is the negative charge. That's the reason why when the charge is positive, ato na siyang minusan og isa para nga musikat ang electron. Okay, when the charge is negative, ato pag na siyang punan og isa para kaninyang, since sikat gyud ang electron. Okay, so ayon ninyo libog-libuga inyong self, just follow the equation here. So just remember, the number of neutron is equals to the number of proton plus or minus the atomic number. If the charge is positive, then you are going to minus or to subtract. If the charge is negative, then you are going to add. For example, this one. Okay? So in some of your periodic table, you can see below the atomic weight that is the charge. Okay, that is the charges. Some of the periodic table or some of the element has 1 or 2 charges. So if you are going to use that one, then just refer on the first in the left sa periodic table, first in the left. For example, in sodium, +1, then separated by comma, -2, the next one. So just focus on the first one at the left side. Okay, this one, the first nga makita ninyo. Okay, for this one, the sodium, the charge, for example, sodium is a charged element, or the charged element, then the charge here is +1. What you're going to do, using the equation above, this equation here, you are going to look for the number of electrons. So number of electron equals the number of proton. How many proton in the sodium? The element sodium is 11. So what you're going to do, since the charge is positive, you are going to -1. Okay, you subtract because the charge is +1. Okay, here +1. Okay, how many electrons do you have now is only 10. Okay, there are 10 electrons for sodium, considering that sodium is a positively charged element. So plot now, you are going to plot using the planetary model of Niels Bohr. So sodium here, you first remember the process. First is we are going to write the first shell that contains two electrons, I mean. Okay, 2 electrons. So fill in with 2 electrons. So na fill in na nimo din ha. So there are still another 8. So minus 2, 10 minus 2, you have 8 more. So add another shell. Then you remember that the second shell can hold up to 8 electrons. So you put that 1, 2, I hope that you can see my cursor. 1, 2, 3, 4, 5, 6, 7, 8. So count all in all, the total for this is 10, which is you have now the 10 electrons. So you don't need to add another shell. Why? Because you have the total number of electrons now. Okay? You don't need to add more shell, I mean. Okay? Now, let's put the configuration here below. The configuration is the total number of electron each shell. So configuration 2, where did we get this 2? That will be from the first level, the first energy level. The second one is 8. So that your configuration, the total of your configuration should equal to your answer here. Okay? So understand? So the total number of your configuration is the total number here. So the first level is 2, that's the reason why you put 2 here, and the second level is 8, that's the reason why you put 8 here. So total number is 10, considering that sodium is a charged atom, okay, or a charged element. Now, number 2 example. If the charge is negative, for example, this is AO or the aurum or the gold, okay, the gold, considering this is a negatively charged element, we have here the negative 1, and the atomic number of gold is 79. So if this is 79, so we can say that this one has, or the number of proton here, what happened? Okay, the number of proton here is, for a while, okay, considering the number, this is 79, considering that the number of proton here is the number of proton, okay, the number of proton, then the positively charged is 79. Okay, since this is a negatively charged, the same equation here from above, which is the number of electron is equals to the number of proton, which is 79 plus 1. Why did you add? Because the charge is negative. That means you are going to add 1 electron. Okay, you are going to add 1 electron. So 79 plus 1, your answer will be, your number of electron is 80. Okay, so pertinang daghana. What are you going to do? In your activity class, in the next page, you can use either X or dot. Okay, X or dot. If you are confident, or if mas plaster sa inyo mo write og X, but here the negative side for this one sa X is when the element or the electron kaninyang position is very close to each other, kani kung magbutang kag X diari, dili gid siya maigo. Okay, that's the reason why I use dots. Okay, I created this one and I use dots. So if you count this one, if you count this will be equal to 80. Okay, the configuration, if you total this one, is equals to 80. Okay, so let's proceed to our activity. So the activity 2, if you have more questions, you can PM me directly. You can send a message to my messenger account for more explanation. So here in the activity 2 is the historical development. You are going just simply to put the letter of the correct answer from column B. So remember, you have to read the instruction before answering. So read first the instruction before answering, because I put in the instruction to write the answer in a capital letter, but in some of my activities in my previous modules, there are several of you who did not follow the instruction. Okay, so we lapas na ta, 34 minutes. Okay, just fine. Okay, so just match column A with column B and write the capital letter of your choice. Okay, you have to make the right choice. Next activity here is the activity 4 is for multiple choice. You are going to read our module because the questions here comes from the module. Now, the activity 5, which is the position of electron. So I told you, you can use dots or X. So you have to remember, for example here, the element krypton has 36. You are going to use the formula, which is number of electron. Considering this is a neutral atom, you don't need the formula here. In letter A, okay, in letter A, you don't need the formula anymore since this is a neutral atom. So in a neutral atom, the number of proton is equals to the number of electron. So kung pila ka book din ha ang atomic, kung pila ang iyang atomic number, then that will be the number of X or a dot nga inyong ibutang dire. Remember, you have to refer the number of charges, the number of electron in the table above. So you have to remember that in the first level here, it can only carry up to 2. The second has a capacity of 8. The next is 18. The next is 32. Okay? So you have to remember that one. Okay, we have here in the letter B, is a charged element. Here you need the equation, which is the number of electron is equals to the number of proton plus or minus the atomic charge. So here in the B, in oxygen, you have to, what you're going to do when the charge is positive, here the oxygen, the charge is negative, then you are going to add. Okay, you have to remember that, when the charge is negative, you are going to add. When the charge is positive here, okay, when the charge is positive, you are going to subtract. Okay, there are two positively charged here, the silicon and the zinc. Okay, so I think that's all for our activities. Just use X or dots for this, and don't forget to write the configuration below. The configuration in the first energy level, how many electrons. Okay, just refer on the example in page, in page 4 of your module. Okay, so just refer there. Okay, for the IFL is you are going to write your own IFL. You are going to write your own integration of faith, learning, and life. You are going to relate our lesson to a biblical perspective. Just make it simple, short and simple, but dili lang pod nga kanang phrase lang pod. Okay, so thank you so much for your participation. I hope that you will watch this video. Don't forget to like and subscribe. Joke lang, no? Nag-practice ako sa pagkakuan. Okay, but anyway, hoping that you will understand our discussion. There will be another discussion which is more complex than this one, so I hope that you will we need focus on our study, especially we are dealing with these elements, mga chemicals na din. And the next discussion that we will be having will be more on solving, mag-solve mga gas laws na in the long run. Okay, so God bless everybody. Have a good week for you. So finish this module within this week. So that will be time is 7 to 12. So you have only the deadline for this module will be this coming Monday. Okay, will be this coming Monday. Okay, so I think we're done. So let's have a prayer before we will end. Shall we pray? Gracious Father in heaven, we thank you so much for the discussion that we have. Thank you so much, Lord, for your goodness. And I pray, dear Lord, that you help the students, give them wisdom, that they can understand our topic, that they will learn something, that they will help them also in their academic pursuit. Guide them, dear Lord. Bless their family as well. Thank you for everything. Keep us safe in this time of pandemic. In Christ's mighty name we pray. Amen. Okay, so God bless everyone. Goodbye, and keep safe.